Welcome back to the Digilent Physical Computing Kit for LabVIEW tutorial series. I'm Sam Christoph from LabVIEW MakerHub, and in this section, we'll learn how to read the state of multiple buttons on the ChipKit WF32. Then we'll modify our code to create a counter that increments when one button is pressed and resets to 0 when another button is pressed. In LabVIEW, I'll choose Help and Find Examples. Then I'll click the Search tab and search for links. I'll double-click the digital read N-channel example to open it. I'll close Example Finder, and in the serial port section, I'll choose COM4, which is our chip kit. The digital input channels I'll set to 65 and 66, and that corresponds to button 2 and button 3 on the chip kit. I'll right-click on the third element and choose Data Operations, Delete Element to remove that element, since we only have 2 buttons to read from. And I'll also shrink the values indicator, since we only want to look at the first 2 values. Then I'll click the Run button to run the VI, and once LabVIEW establishes a connection to the chip kit, I can press button 2, and the first LED lights up. Button 3 will light up the second LED, and if I push them both at the same time, both LEDs light up. Let's take a look at the code. I'll click the Stop button, and then press Ctrl E to bring up the block diagram. You can see, like usual, we use the links initialize VI to establish a connection to the device. Then inside the while loop, we use the digital read N-channels VI. We pass it a U8 array, which indicates which digital channels we want to read from, in this case 65 and 66. This VI outputs a Boolean array, which represents the state of those channels. Outside the while loop, we close the connection to the links device and then handle any errors. Let's update this code to create a counter, much like we did in the last section, but also include a reset button that'll reset the count value to 0. I'll move the digital read over to give us a little bit more room, and I'll expand the while loop. Just like before, we'll use a shift register for the count value. I'll right-click on the edge of the while loop and choose Add Shift Register, and then I'll press Control Space to place a numeric constant to initialize our count to 0. I'll do the same, right-click on the edge of the while loop and choose Add Shift Register, and place a false constant to initialize the previous button state to false. Now we want to store the value of the button, but we have an array of button values, not just an individual button. So we'll use the index array primitive to extract a single button value. I'll pass it the array of values, and I'll right-click on the index and create a constant. We'll set it to 0 to pull out the first element. This will be our count button, and I'll pass that into the right shift register to store it for the next loop iteration. Now, if you remember last time, we wanted to AND the current state of that button with the previous state and use that to determine if we should increment the count or not. So I'll place an AND primitive in a case structure, and we'll AND the current button state with the inverse of the previous. So I'll place a NOT and wire in the previous button state. We'll wire this to our case selector, and if it's true, that means that we should increment the count. So I'll pass in the count value, an increment primitive to increment the count. I'll pass that out into the shift register, and I'll switch to the false case. We don't need to increment the count in the false case, so I'll pass the value through. So now we have a working counter that we can increment, but we can't clear it yet. In order to clear it, we need to look at the value of button 3. I'll hover over the index array and grab one of the bottom handles and click and drag to expand it. This will give us the next value in the array. So since we have value 0, this will be value 1, which is our other button. If this is true, we'll reset the count. If not, we'll just leave it as it is. So we can do this with a select statement. I'll use quick drop to place the select, and I'll place it after our case structure. If the button is true, we want to reset the count. So we'll create a constant of 0 on the true case. If it's not, we want to keep the current count value. So we'll pass in the count value, and rather than passing that into the shift register, we'll pass the output of the select into the shift register, and we'll also use an indicator to display that on the front panel as our count. I can do that just by right-clicking on the wire and choosing Create Indicator. I'll rename it Value, and I'll clean up the code just a little. Now I'll double-click Value, and I'll move it into a more convenient spot, and let's run the code. Once LabVIEW establishes a connection to the chip kit, I'll press button 2, and you can see the LED lights up and our count increments. If I hold it, since we're doing debouncing, it doesn't increment unless I release and press again. If I press button 3, the count resets to 0. Again, I can increment it using button 2 and press button 3 to reset it to 0. So that does it for our simple example of using multiple buttons on the ChipKit WF32. But think of other things you could do with multiple buttons. Like, for example, maybe one button could count up, the other could count down, and if you press both buttons at the same time, you could reset the counter. You could also update this code to have a user-defined minimum and maximum value. Make sure to join us next time when we learn about reading analog values from the potentiometer on the ChipKit WF32. Make sure to check out LabViewMakerHub.com for more tutorials and projects, and ask any questions you have on the MakerHub forums at LabViewMakerHub.com/forums.